Okay, let's take a look at what we need to do now so that we can consume an event that's been passed on to the service bus. So inside the search service we're doing this. This is going to be the consumer of the event. So inside the search service, I'm just going to right click, add a new folder, and I'm going to call it consumers. And inside our new consumers folder, I'm going to add a new file. And it's going to be a class, and I'm going to call this auction created consumer. And please do use the consumer at the end of what you've put here, because like I say a few times, mass transit is convention based and it's expecting our consumers to be called consumer or something consumer. And it uses that for its name formatters for the exchange and the queues that will be created based on our code. So please do stick with conventions, because it means we write a little bit less code and we don't need to worry too much about the formatting of names of things when it's being created by conventions, as it is here. So we've got an auction created consumer, and this is going to use the iConsumer interface that we get from mass transit. And this takes the type of thing that we are consuming. So in this case, it's going to be the auction created that we get from our contracts library. And because it's an interface, we're required to add its required method. So we're going to implement the interface using the quick fix. And this requires us to supply a consume method. So we need to map the auction created effectively into an item so we can update our database. And do we have mapping profiles in here yet? We do not. But I'm pretty sure we installed AutoMapper earlier. Let's just double check. And we do have AutoMapper. And if I take a look at the program class, did we configure it? We did not. So I'm just going to add the configuration for AutoMapper inside the program class for the search service. And I'll say builder.services, and we're going to say add AutoMapper. And we just need to provide it with a configuration. So that's going to be app domain and current domain, and not base directory. I'm going to say get assemblies and close this off with a semicolon. And we'll also provide a mapping profile so that we can go from the auction created to the item, which is what MongoDB needs to save this as. So we're going to request helpers, and we'll add a new file, and we'll add a new class, and we'll call it mapping profiles. And this is going to derive from the profile class in AutoMapper, and then we create an empty constructor, just as we have before, and we're going to create a mapping. And this is going to go from auction created to the item that we have inside our search service. We don't need to provide any configuration. These are more or less identical. So AutoMapper will be perfectly capable and happy with mapping from one to the other. So back in our auction created consumer, now that we know that we're using AutoMapper, we can inject AutoMapper into this particular class. So I'll add a constructor. So we can use dependency injection, and we'll add iMapper and call it mapper, and we'll just use the create and assign field mapper in here. So into the consume method, what do we want to do when we consume this particular message when it arrives from the service bus? Well, first of all, let's make it an async task so that we can use the await keyword inside here. And first of all, let's just add a console.writeLine, and we'll just add not consume. I'll get rid of that, but we'll just add a message or a line inside here saying consuming auction created, and we'll just specify the ID of the auction. So we'll say context.message. And inside here is all the properties of the auctions. We have our image URL, the sold amount, the auction end, the color, the created at, etc. But I'm just going to put the ID in here as what I'm going to put in the console when this happens. And then we need to create the item from the message. So I'm going to say var item is equal to mapper.map, and we're going to go into an item, and we're going to get that item from the context.message. And once we have the item, we can then save that into our database. And we can say await item, period, save a sync, which we should be able to use. And we can use MongoDB entities, which provides that functionality. Now we don't get anything back from this. This is just returning void, so there's nothing we can do theoretically to check. But if the database save fails, then this should throw an exception if this particular line of code does not work. But we'll take a look at dealing with faults in mass transit soon, but not now. We're just looking at the happy path. So now that we have a consumer, we do need to tell mass transit about this consumer. So we'll go to the program class inside the search service, and where we've got our add mass transit, we need to tell it where to find the consumers that we're creating. So we have a method to help us with this, and we'll say x.addConsumers from namespace containing, and then we can specify the name of our consumer that we've just created, which is the auction created consumer, and effectively any other consumers we create in the same namespace are automatically going to be registered by mass transit. Now there's one more thing I want to do inside our configuration in here, because I do not like the default formatting of the names for our consumers. Because if I, in a different service, create another auction created consumer, because multiple services need to do something when an auction is created, then I'd need to add some extra stuff onto the name of the class so that it's different from the other service that's consuming the same consumer. And all we need to do to achieve that is add an extra bit of configuration in here to set the endpoint name formatter. And I'm going to specify new kebab case endpoint name formatter, and then provide it with a prefix that it's going to use in front of the queue name, and it's also going to use kebab case, and kebab case is s-d-s whatever, but it's going to put a dash in between the words rather than using title case. And I'm just going to have a prefix of search to represent the service that this queue represents. So when it comes to creating the queue, it's going to be search-auction-created. And we just need to add an extra thing on here, and we'll set that to false. And the false represents, do we want to include the namespace with the formatted name? So I've set that to false. We don't want to include contracts with this formatted name. We just want the prefix in this case. So with this configuration in place, let's take a look at what happens when we restart our search service. And we've got the, do we want to restart our app? I'm just going to say yes in this case. And the application's restarted. Looks like I've got an issue with the HTTP request we looked at in the last section, because I wasn't expecting that to be 10. I would expect that to be 0. But please ignore that for now. I'm going to address that at another time and add a call out or something, depends on what I've done wrong, regarding the date in that. So whenever you see that, please ignore it. This request, by the way, is technically idempotent. Every time it's going to do the same thing and will end up with the same results. Because the way that MongoDB works, it's going to overwrite any of the documents that it already has, so long as they have the same name or the same ID. But please ignore that if you see that inside here. I'll deal with that another time, because I want to keep moving forward with asynchronous messaging. So let's go back to RabbitMQ management, and what we should find in our exchanges is we have 2 new exchanges. We have the exchange for the contracts, auction created, and we also have another exchange for search, auction created. And the way that mass transit approaches RabbitMQ is it has exchanges that send to an exchange, which send to a queue. So with the contracts auction created, let's say we publish a message from our auction service, that's going to go to the contracts auction created, which will then forward that onto exchanges that are bound to this exchange, which in this case is the search auction created exchange. And then this search auction created exchange has a queue, also called search auction created. Sounds a bit weird, and it sounds like we've got one more exchange than we need to, but that's how it works in mass transit, and it works just fine. But now we've got a queue ready to receive messages for our search service. So what we'll take a look at next is how we publish a message to that queue so it can be consumed by the search service. Oh, and by the way, before I go, I know we talked about the exchanges in the last section. By default, these are created as fan-out exchanges, and we would need to change that if we wanted a different type of exchange, but we do not. We're happy with fan-out exchanges. That's exactly what we need for what we're building here. So in the next lesson, we're going to take a look at publishing a message.